Welcome to Unique Academy YouTube channel. So in this video, we will see gate problems from thermodynamics. See, air at a pressure of 1 MPa and 300 Kelvin is flowing in a pipe. And so there is a pipe. So there is a pipe through that air is flowing. Air is flowing in a pipe. An insulated evacuated rigid tank is connected to this pipe through an insulated valve. So through a valve, you are connecting a tank. So the air pressure of 1 MPa, maybe we take it the air pressure PA, air pressure is 1 MPa, PA is a air pressure, and air temperature of the air flowing in the pipe is 300 Kelvin. So an evacuated rigid tank. So evacuated rigid tank. So that means initially tank is in vacuum. So the volume of the tank is 1 meter cube. So volume of the tank is 1 meter cube. So the tank is insulated. So it is insulated. So heat transfer will be 0. So when the valve is opened, the tank is filled with air. So we open the valve. So air is flowing into the tank. And the tank pressure, maybe the initial pressure is vacuum. Tank reaches a final pressure of 1 MPa. Maybe the tank initial pressure, we take it 0 to the final pressure of 1 MPa, the flow stops. Till the time it will flow. Corresponding to this initial condition, the mass inside will be 0. Corresponding to this final pressure, there will be a mass inside the tank. Is the final mass, which we don't know. Okay, so from initial mass 0, the tank is filled with a final mass mf. So once the flow is stopped, the valve is closed. Consider air to be an ideal gas. Neglect the bulk kinetic and potential energy. The final temperature of the tank, air in the tank. So what is the final temperature of the air in the tank? So this is what. So now, here we will apply the conservation of energy principle. We take the energy in. So conservation of on the tank. So you take a tank. So there will be a energy in. minus energy out equal to change in energy of the system. This is your conservation of energy principle. Now, if you take the tank, so this is the tank. So there will be a energy going into the tank. So what is the energy going into the tank? The mass is going into the tank. What is the mass that it is going into the tank? So the mass going into the tank is the final mass inside the tank minus the initial mass inside the tank. So the difference, because you have initially maybe mass is 0 because of the vacuum in the tank. But you assume that initially there is a mass. Then after the mass is filled, air is filled in the tank, you have a final mass. So that difference in mass is what is going through the inlet. And since the mass is flowing, it will have enthalpy. So maybe that enthalpy, we take it, maybe air, enthalpy of air. Okay. So the energy going, and kinetic energy and potential energy are neglected. So the mass flowing at the inlet is mf minus mi, the difference in mass, final mass minus initial mass, that is flowing. Since it is flowing, it will have enthalpy. And so energy in will be your final mass minus initial mass into enthalpy of air. Energy out will be 0 because there is no energy going out. Energy out will be 0. Then change in energy. So what is the energy changing? The internal energy inside the tank is changing. Inside the tank, there is no movement. There is no flow. So it will have only internal energy. So the change in energy will be final internal energy minus initial internal energy. Change in internal energy of the mass inside the tank. Now, as we know that the initial mass will be 0, so we take initial mass 0. So this initial mass will be 0. Then what you get? Final mass into enthalpy of air, final mass into internal energy of the final internal energy. And we know that air being an ideal gas, so it is an ideal gas. So H equal to CPT, U equal to CVT. And final mass, both the side final mass will be getting cancelled. So Cp of the temperature of the air, Cv into the final temperature. So the final internal energy will be Cv into final temperature of the tank. So we want the final temperature. It is Cp by Cv into temperature of air. Cp by Cv is gamma. Gamma for air, it is 1.4. So gamma for air is 1.4. So gamma is 1.4 for air. Maybe since if you wanted to calculate it, and you can calculate because Cp is equal to gamma R by gamma minus 1, right? Cp is given 0.5. So both R and this Cp is in kilojoule per kilogram Kelvin. So 1.005 gamma minus 1.005 0.28. So gamma is 1.399. So it is 1.4. So gamma is 1.4 from the given CPC and the R of the air. Then the final temperature will be, so TF 1.4 into temperature of air is 300 Kelvin. (420 Kelvin). So this will be your answer. 420 Kelvin is your answer. So now we move to the next question. So a frictionless piston cylinder device contains 1 kg of ideal gas. So you have a piston cylinder device. So that means it is a closed system, frictionless, contains 1 kg of an ideal gas. So mass 1 kg. The gas is compressed. So the work is given in. And it is according to PV power N equal to constant, where N is 1.3 in this case. So from the initial pressure of 100 kPa and initial temperature 250 Kelvin till it reaches to the final temperature of 500 Kelvin. The heat transfer from the piston device to its surrounding. So heat transfer, maybe, so this work input, we will take it work transfer in the process 1 to 2. So heat transfer in the process 1 to 2. So there will be an internal energy change. Okay. Because for PV power gamma, PV power N equal to constant, you have an internal energy change. So now, so we write the first law of thermodynamics. Applied to closed system undergoing a process 1 to 2. So that is Q1 to 2 is equal to W1 to 2 internal energy change. So W1 to 2, because it is a polytropic process, integral PdV work. So that can be got separately, W1 to 2, integral PdV 1 to 2. So we know that, so PV power n equal to constant, P equal to C by V power n, C dV. One to two. So C you can write. So C can be written as P1 V1 power n as well as P2 V2 power n. So if you write maybe for the first case P2 V2 power n into V2 minus n plus 1 minus second limit is 1. P1 V1 power n V1 power minus n plus 1 by 1 minus n. So this you will get P2 V2 minus P1 V1 by 1 minus n. So that is P2 V2 minus P1 V1 by 1 minus n plus U2 minus U1 is mCV into the temperature difference. And since we are knowing the temperature T1 and T2, so we know that it is an ideal gas. So you are given ideal gas, right? So from the ideal gas, we can write PV equal to mRT. So PV can be written as mRT. So this can be written as mR into T2 minus T1. P1 V1 minus P2 V2 can be written in this format. 1 minus n CV into. So now we can substitute the values. Mass is 1 kg or 287. So mass is 1 kg, 287 joule per kilogram Kelvin. So the answer you will get in joule into 500 minus 250 by 1 minus 1.3. CV is, it is air. So CV for air is 718 joule per kilogram Kelvin. Maybe this CVCP for air or for air, those things you must remember. 718 into the temperature difference, 500 minus 250. So let us see what you are getting. You must get negative sign because heat is going out. So that indicates the sign is negative. Let's see. So minus 5966.67 joule. So this is negative sign indicates that heat is going out. So this you can write in terms of kilojoule. 59 minus 59.67 kilojoule. So the heat transfer will be negative because the heat is going out. So in this equation, Q122 is equal to W122 plus U2 minus U1. The heat transfer is coming out of the system, then your sign will be negative. Heat is going into the system, sign will be positive. So what is asked is the magnitude, 2 decimal places. So 50, only magnitude you write. 67 kilojoule. Now, if you look at that, internal energy change is positive. So you can see 718 into 250 internal energy change. So your change in internal energy is greater than 0. So work is going into the system and work output will be negative. So this W1 to 2, you will get a negative value from the equation P1, P2 V2 minus P1 V1 by 1 minus N. That will give you negative sign because work is given into the system. So now the work which is given into the system should be greater than heat going out of the system. So that is the reason why your U2 is greater than U1. Because energy of the mass is getting increased. That is why change in internal energy is positive. Because you give work output, that will be more than the heat which is going out in the process PV power gamma 1.3. So we move to the next question. Point 0.8 meter cube of insulated rigid tank. So an insulated rigid tank. So heat transfer will be 0. Because of insulated. Volume will be 0.8 meter cube. Mass inside the tank 1.5 kg. At a pressure of 100 kPa. Electric work is done on the system. So there is a electric work done on the system which raises the pressure. So this electric work, so maybe this is the electric work input, electric work. Maybe which you can take it I squared RT. So this is the electrical work input given in the system which raises the pressure 135 kPa. Your volume remains constant. Volume, there is no change. Volume is constant. The loss in availability associated with the process. The ideal gas characteristic gas constant. So R is given as 188.9 joule per kilogram Kelvin and CV is given as 680 joule per kilogram Kelvin. That means CP will be CP minus CV is R. CV plus R. CV plus R, 680. 0.9. 868. 0.9 CP. So now the loss of availability. Loss of availability is nothing but irreversibility. Irreversibility is T0. T0 is the atmospheric temperature. So the temperature of the dead state. So atmospheric temperature is given as 298 Kelvin. T0 into entropy generation. Okay. So now we need to calculate the entropy generation. Or this is nothing but T0 into entropy change of the universe. Entropy change of the universe is equivalent to entropy generation. Now, if you take this insulated tank, so there only work is going into the system. So the work doesn't transfer entropy. So the work doesn't transfer entropy. That means entropy transfer in this system is zero. So if you take an entropy balance, entropy in minus entropy out plus entropy generated is equal to change in entropy of the system. So there is no entropy in here. There is no entropy out because there is no heat transfer or mass transfer. When you have heat or mass transfer, then you have an entropy transfer. So entropy in and out will be zero. Entropy, no entropy transfer. So entropy generation. Entropy generation is nothing but entropy change of the universe. Because this, if you consider as the universe, so this can be considered as the universe because this can be considered as the universe. Whatever inside, because of the process, there will be an entropy generation. So that is the change in entropy of the universe. Okay, so entropy generation equal to, so that will be entropy change of the system. Entropy change of the system is S2 minus S1. Entropy change of the system. Now we need to find out entropy change of the system. And there are two equations through which you can find TDS equal to DH minus PdV. Sorry, minus VdP. This is one. Another equation is TDS equal to du plus PdV. So any equation you can use it. And it is preferable to use the second equation because volume is constant. So change in volume will be, this is equation 1, this is equation 2. It is preferable to use say, equation 2 because so volume constant. So this will go to 0. You get TDS equal to du is CV dt. ds equal to CV dt by t. S2 minus S1 if you integrate from 1 to 2. It is CV ln T2 by T1. And we know that for volume constant from this PV is equal to RT. ratio of pressure P1 by P2 or P2 by P1 is equal to ratio of temperature. Take ratio, you will get this. So T2 by T1 is P2 by P1. That is 135 by 100 is your T2 by T1. 1.35. CV, you are given CV 680 ln 1.35. This will be in joule per kilogram Kelvin. Okay, so we want in kilojoule. So let us come back to that. So this will be 680 into ln 1.35. 204.07 joule per kilogram Kelvin. So now we wanted this in joule per Kelvin. So multiply by the mass 1.5 kg. So the entropy generation, so maybe this if you multiply by mass, you will get entropy generation in entropy generation is equal to m into S2 minus S1. M is 1.5 kg multiplied by this 204. So this is your S2 minus S1. Three not 6.11 joule per Kelvin. So now this irreversibility I, irreversibility T0 is 298 into this 306.11. So this product you will get in joule. Nine one 220.78 joule. This we wanted it in kilojoule. So 91.22 kilojoule. So this will be your answer. So 91.22 kilojoule is your loss of availability. Loss of availability is the destruction of available energy, which is nothing but irreversibility. Now we move to the next question. So a rigid tank contains 1 kg of pure water. So rigid tank contains 1 kg of, so mass of pure water consists of liquid and vapor phases in equilibrium. That is mass of liquid plus mass of gas together is 1 kg. It is in equilibrium and at 10 bar. So the pressure is 10 bar. So here you have a liquid and the gas. Okay, so mass of gas, mass of liquid. Together 1 kg. If the liquid and vapor phase each occupies half of the volume of the tank. So if you take the volume of the tank is V, so the liquid will occupy V by 2, gas will occupy V by 2, half of the volume. So what is the net enthalpy content of the tank? So what is the net enthalpy content, enthalpy? So this will be in kilojoule. Maybe first you will get the joule per kilogram, and then so Trainus fraction into HFC. So this will give you net enthalpy, but we need the Trainus fraction. So you are given HF, Hg. So knowing X, you can get HFG. So how do you calculate X? X will be nothing but mass of gas by mass of fluid plus mass of gas. So this is the total mass. Yeah, 1 kg. Now here we know that the mass of the fluid is Vf by specific volume. So this is meter cube. This is meter cube per kg. You will get mass of the fluid. Similarly, mass of gas, Vg, sorry, this will be the total volume, Vg, by specific volume, meter cube by meter cube per kg. The specific volume is given here. So we will get the total volume. So mass of fuel, Vf will be equal to V by 2 into Vf, 1.127 into 10 power minus 3. So let's see how much we are getting. For 43.66 V kg of similarly mass of gas V by 2 into Vg 194.3 into 10 power minus 3. Two point 57 V. So this Trainus fraction mg is 2.57 V by 443.66 V plus 57 V. V is common, so that will get cancelled. So now you get to the Trainus fraction. So this dryness fraction is 0.006. Okay. So now we can get to the HF will be 762.6. Maybe it is in kilojoule per kilogram. So you get the answer also in kilojoule per kilogram. Plus X is 0.006 into, we know that this HFG equal to Hg minus HF. Hg is 2776.2 minus 762.6. This is your H. So 774.68 kilojoule per kilogram. So the net enthalpy content in kilojoule. So from here, if you say net enthalpy, that will be the mass into H. Mass is 1 kg. H is 774.68. Okay, so mass is 1 kg. This will be 774.68 kilojoule. Okay, 774. So answer is 774.68 kilojoule. So now we move to the next question. So the energy equation for a reversible non-flow process is expressed as, so delta Q is equal to du plus PdV, where Q is the heat transfer per unit mass, U is the internal energy per unit mass, P is the pressure, V is the mass specific volume. This energy equation is not exact differential form. It can be made exact differential by multiplying the following integrating factor. So why this equation is not exact? So U, internal energy is the property, P is the property, dV is the property. dV is the property change. But the Q is not a property. So Q is the path function. That is why this equation is not exact. If the equation is specified by only properties, for example, you have TdS equal to du plus PdV. TdS equal to dH minus PdV. So these are all exact differential because the differential equation is defined by properties which are point function, which it doesn't depend on the path, depend only on the point. So to make this point function, we know that dq by t equal to ds. So if you multiply by 1 by t, maybe dq, delta q is dq only, du by t plus p by t dv. So this dq by t can be written as ds. One by t into du plus p by t into dv. Okay, so this will be an exact differential. So the integrating factor is 1 by T. So 1 by T is an integrating factor. So this will be the answer. So thank you for watching this video. If you are happy with this video, please subscribe the channel and share this video to your friends who are preparing for GATE mechanical engineering subject. If you want to join for GATE 2026 video course, please contact in this number and you can just go to the website and thank you.